We are now in section 1.4, day 1, beginning a new unit, but we are continuing off of where we left from last unit. Last unit we were talking a lot about domain and range towards the end. We're going to be using that a little bit today, but the main goal of today is just going to be building functions from other functions. And to start with, we'll talk about add, subtract, multiply, and divide. We'll kind of get it all taken care of in one big example. So we're going to be adding, subtracting, multiplying these functions together, and then I also want to talk about domain after we get those. So first of all, f of x plus g of x. That's about as simple as it can get, at least in this example. We just combine like terms, and so from these two, it looks like we just have x squared and then plus 3x. Those don't have anything to combine with. Then we got plus 5 minus 5, so that's just 0. So that ends up being our function. We want to find the domain of this function. And the domain, as we talked about in the last unit, we're looking for the red flags. We're either looking for divide by 0, or we're looking for negatives in the square roots, or both. In this case, we don't have either. As I mentioned last unit as well, most polynomials, or most things that we're going to be dealing with, will have the domain of negative to positive infinity, and this one does too. F of x minus h of x, a little bit different here. We've got 3x minus 5 as our f of x, minus h of x, which is square root of x plus 2. Now with this one, there's really nothing else we can do to combine this. We just have to find out what the domain is. But the trick is that when you do combine different functions together, you have to use for the domain the most restrictive part of the domain. Now whenever we have a square root, one thing that we can do with that is just to set whatever is underneath there greater than or equal to 0. So sidebar over here, x plus 2 is greater than or equal to 0. Subtract the 2 from both sides. X is greater than or equal to negative 2. All right, so I've got x is greater than or equal to negative 2, but I want to state that in terms of interval notation. So that will be negative 2 on the left to infinity, rounded bracket, on the right. So there's my subtraction example. For my multiplication example, this one, I'm not going to foil out all the details, just want to show you where we would go with this. F of x is 3x minus 5. G of x is x squared plus 5. If we were doing this in the homework, we would be foiling it all out, simplifying it, that kind of thing. And you would find another situation, kind of like the first, where we don't have any divide by 0, we don't have any square roots, and so our domain would end up being negative to positive infinity once again. Save the best for last, and that is division, because division is going to be really the weirdest one in this case. H of x divided by f of x. I meant for this one, the way I built this one was to give you a little bit of everything in here in terms of domain, but we're going to have squared x plus 2 divided by 3x minus 5. So we need to find the domain for this one. It can't be simplified. This is the simplest form of the function that we have here. Oftentimes that's going to happen with division. But as far as the domain goes, we have to use the most restrictive part of the domain, so we have to find out what are the restrictions first of all. So the restrictions on this one, we already did the x plus 2 thing. We saw that over here, that it was x is greater than or equal to negative 2. So that is one of the restrictions. Another restriction is going to be from down here. We don't want this to equal 0, so I'm just going to go 3x minus 5 not equal to 0. I'm going to solve that, add the 5, 3 not equal to 5, 3x not equal to 5, then divide by 3, so x is not equal to 5/3. So that's another restriction that I have here. Now with this one, if we're going to find the domain, we want the domain to be in terms of interval notation, and my suggestion here is that you graph it on a number line first. That'll make it a little bit easier. We've got the restriction over here of x is greater than or equal to -2. I would start with that because we got -2 down here. It's going to be a closed dot because it's got the equal to bar, so that we'll just label that as -2. Then we're going to be shaded up from there. And now we just have to look at this other restriction. Now this other restriction is that x cannot equal 5/3. 5/3 is greater than -2, so we'll just place it over here. It can't be that, so we're just going to shoot a hole in that line. Now if it were over on this side, then we would just ignore it because it wouldn't matter anyway. It wouldn't be a part of the domain anyway. Here, however, it does matter. So I'm going to describe two different chunks in this case. One of those chunks is going to be from -2 to 5/3. So in interval notation, that'll look like this, with a rounded bracket around the 5/3 because that is a hole. And then the other part of it is just going to be the right-hand side, so I'm going to put a union in between, then start right back up on 5/3, and that goes up to infinity. So that one's a little bit more of a complex domain there. But with all of these, we just want to we want to find out what is the most restrictive part of the domain once we have simplified the original function.